Alrighty, has that
Got
come
you.
up on the screen? All right, well, so thanks everyone for having me here. I think Joe and I have had various chats over the last, goodness, must be a couple of years now. And yeah, I guess no, thanks Joe for thinking of us to give you a bit of an update on where we're up to and what we're doing. So I guess, sorry, maybe today I'll talk about I guess the two projects we're working on, maybe a bit more time on the first one, which is our Collie rebar mill, which is probably a lot more mature, and then I'll touch a little bit on the second plant, which is a DRI plant, which we're also developing in the Midwest. So I might just blast quickly through this. I think everyone on this call is pretty much here for the same reason, that steel is a fairly significant contributor to global CO2 emissions, and it's I guess it's a very difficult area to fully decarbonize. So I think we're all here because we agree that something needs to be done, and it is a challenge. So I probably won't spend too much time on this. The other interesting little fact is that Australia actually plays a significant role in global CO2 emissions. We're the largest exporter of iron ore in the world, and our iron ore actually results in over 1 billion tons of CO2 production every year. One of the interesting things was, I think, one of the large iron ore producers in Australia potentially produce actually more Scope 3 emissions than the LNG exporters, or a comparable amount. It's quite an interesting. We're very focused on Scope 3 emissions from the resource industry, but it's interesting that the Scope 3 emissions from iron ore aren't that far off from Scope 3 emissions from gas exports. But maybe on the other side, it's both a problem and an opportunity. Is that iron ore becomes, the $100 or so billion of iron ore that we export every year becomes $600 billion of steel, which means that someone else is deriving $400 billion of value. So I'm not saying we'll get it all, but even some of that would be pretty significant to the country. And so, and I guess we haven't, and the steel industry has probably been fairly, I guess, it's sort of stayed the same for a long time. I think for the last 3 decades. So the next thing I was going to go through was, I guess, a few and some, I guess, sort of the pathways and the ways that we can get to reducing steel emissions. So typically the simplest way to reduce steel emissions is to recycle as much as we can. I know it's not the solution to the whole problem, but it definitely is. The technology is there. You can produce steel with very low emissions through recycling, and it's I guess. And there are other benefits from recycling as well. Besides reducing emissions, you also end up with less mining, less energy usage overall. So again, it's a relatively easy but not a big step. And then the next thing out there is using existing DRI technology, either with gas or hydrogen or CCS in the middle. And that's, again, proven technology. It has the potential to make a bigger impact than recycling, especially in Australia. But it also isn't the whole solution, because while there are quite a lot of magnetite resources which can be enriched to support existing DRI technologies, it doesn't solve the big Pilbara problem, which is the nearly 1 billion tons of hematite that we export every year. And that I guess comes with the technology that are coming, like the electric smelting, solution electrolysis that Fortescue and Element Zero are pursuing, and then there's molten electrolysis, which I think Boston Metals and some other mobs are doing, and then there's probably some other ones that we've never heard of that are all there, but I think they're a little while away. They're very, very important. I think they're the solution to everything, but they're probably quite a while away, I guess, because I think they're still at best in pilot stage. Some are not even there yet, and so there's quite a while to go. We think probably a decade plus before they're in to get to a decent commercial scale. So I guess we're currently focusing on the stuff that's already there and done. So it's not I guess not here to solve the world, but just to take a step forward and do something that makes sense. I mean, I guess overall, all of these things need to stack up economically. So we're working on the principle that if it's find a way to make these work within the current environment, and then to set the scene for the next few things. So off the back of that, we've got our Collie steel mill. That's a 450,000 ton a year steel recycling mill producing rebar in the town of Collie in Western Australia that I'll tell you more about. And then our Midwest DRI project. Both of these projects, we've been working with Denali on both of these projects using their MIDA mini mill technology and then their Energiron DRI technology. So the first one is Collie. It's to be, I guess we've been working pretty closely with the state government, who funded a lot of the part of the development of the project. So we're fully funded to FID. As far as technology goes, it's sort of very new and advanced and interesting in steel terms, but it also is just a copy of something else. So I have to admit, we're not by any stretch a technology company developing cool stuff. We're literally just taking what someone else has done and repeating that. But on the converse of that is that there's minimal technology risk in there, and it's hard enough just to get one of these off the ground without technology risk. I can't imagine trying to do this with technology risk. I don't think I'd survive. Being an electric arc furnace mill using continuous casting and rolling, we're expecting it to be the lowest emissions or cleanest from an emissions point of view steel mill in Australia. We've been working pretty closely with the state government. We've been designated as one of 3 or 4, I think, or maybe there's 5 now, strategic projects in Western Australia, and we're aiming for operation in 27. So yeah, obviously it'll need to be fully AS compliant, and we're pretty comfortable that we'll get below 370 kilos per ton of CO2. We can go lower, but I guess that'll depend a bit on the market and all the rest. I mean, this is assuming a mix of renewables and just grid-based power. We'd love to go full renewables, but that's something we'll work through as we go along. But we're expecting to start up at this number and then work our way down from there as things pan up. So yeah, strategic project. Actually, I might blitz through this. An important thing for us was for a project to be both environmentally as well as economically sustainable. Having something that is green but doesn't make money is not a great way to start. So one of the things we're fortunate with is that Western Australia currently exports all of its scrap steel, and it is priced at overseas benchmarks. So believe it or not, scrap steel is cheaper here than in Bangladesh or India. It's not an enormous difference, but every dollar counts. So that helps. Having an efficient mill in the middle that we know will work is sort of the second part. And when you combine that with reasonable energy costs in WA, I guess that means that we get fairly priced scrap, have a good efficient conversion of it into steel. Efficient logistics. One of the over half of the containers, and some numbers say up to 70% of the containers and trains leaving Western Australia leave empty, which is sad and obvious when you think about it. I guess we sell rocks and gas. We don't really make anything here, but we buy stuff. So that is handy from our point of view. I guess it's a lot cheaper to send stuff to the East Coast and even up into Singapore as well. One of the quotes we got for sending a 40-footer to Singapore was -$5 or $10. They said basically they'll give you a $10 fuel rebate if you take the container back for them. So that's sort of because I guess everyone's paying to get empty boxes back to where they came from, and then so that. And all of that, I think, allows us to get the low emissions. Sorry, that should be a 370. I've just realised. Rebar around Australia at a reasonable cost. So now this is. I hope the sound doesn't come up. Let me find a way to kill the sound. So this is a video of Frostproof, which is a Denali mill in Florida, which I managed to kill the sound, which Collie will be a near copy of. So sorry, ignore the solar thermal. We don't have that. I had to use a Denali video, which I should actually remove this portion. And so it's one of the modern mills where you feed scrap in. We've got through a feed conveyor into an EAF, but I think the main difference with that the newer mills have now is that they cast a billet and then immediately roll that continuous billet out into a finished product, in this case rebar. So we can produce DBIL or straight rebar like this. But the other product that we're quite excited about is what they call spooled rebar. I must admit, I'm not from the steel industry and not from the cut and bend industry, and the idea that you can spool rebar up to 24 millimeters is still gets me. I still find pretty amazing. So then, and I've got a second video after this that talks to how spool rebar leads to very efficient cut and bending operations. And so the other, I guess we've also had some economic studies done from by EY on the benefits of the mill, and I guess its jobs and a fairly significant contribution to sort of the state's economy. One of the things that I talked with Joe about was that Collie is an interesting sort of convergence of three important themes, I guess. There's obviously low emissions steel or green steel that we've all talked about, but being a recycling mill, there also is a strong circular economy theme. I mean, we've never recycled steel in Western Australia. We export everything, so it'll be quite a change. So that's something that is pretty exciting here. But the other bit that I don't know whether we've talked about much was, so Collie is sort of like the Hunter Valley of Western Australia. So all of our coal's mined in Collie, and that's where all of our power has traditionally been generated. But the state's planning, as part of decarbonisation, the state's planning to close all of the coal-fired power stations at all of the coal mines by 2030. So they're in a bit of a wind down, and I guess it means that effectively, if nothing's done, the town will just vanish. So we've been working pretty closely with the state on what they call their just transition process, and it's something that's I think a lot of sort of coal towns are looking at all around the world to see how Collie's transition has worked. I think it's Collie, the Collie transition so far has been sort of a great example of how, with a bit of government help and industry participation as well, you can create the just transition. So we'll be the first large industrial facility to get set up in the Coolangatta area in Collie, and then following behind us, there's a company called Magnium who are working on a green magnesium smelter, and International Graphite who are looking at setting up a high quality graphite manufacturing facility. And I guess the joke that I said was maybe we'll be like the Big W in a shopping center, and then get the industrial area going, get some of the infrastructure set up, because we'll be building rail and a few other things in there, and then sort of grow, turn Collie into a green manufacturing center. So in terms of product, we'll be producing the straight rebar that we're all familiar with, but we'll also be in all the usual lengths to the Australian standards, and then spool rebar, which is rebar in coils. And I think one of the neat things about having a local mill is that it's local mills then offer everyone in the downstream supply chain, I guess, a more direct connection to the manufacturers, and also the ability to shorten lead times, customize products, a lot of things that we could do, and probably very similar to other local manufacturers. Anyways, probably one of the benefits of having local manufacturing. I think it's a fairly generic theme across the board with local manufacturing. So spool rebar is really neat. I'm an engineer and I nerd out on these things. So basically, rebar is put in spools, put through automatic bending machines, and shaped. I think for me, automation is what will help bring manufacturing back into Australia. This is the pile cage manufacturing machine, again, that just sort of peels off spool rebar from spools. I think if we are a high labor cost country, and there are many benefits from that, but I think the only way we can have manufacturing here is through automation. So I think spool rebar coupled with lots of automation on the downstream side, I think will help us to create more industry, which then creates more good jobs rather than fewer industries with more sort of lower quality jobs. but that's my personal opinion. So we're working through. We've been working along for a bit now. Next, I think in about April, we should get the very last of our approvals. We've got our planning, development, and environmental approvals of the plant. Unfortunately, there were some trees on site that we've had to do some things for, but I think that's all sorted now. We're just waiting for our final approval from Department of Conservation, and then that'll be the last of our approvals. We've onboarded our preferred contractor for the work, and so the next few months will be a mad rush to finish capital raising, sort out all of our supply and offtake contracts, and then into construction towards in the second half of this year. So any luck, we'll be running by 27. So that's Colleen. I'm going to keep moving along. How are we going for time, Joe? Do I need to cut short to accelerate?
Look, I'd say accelerate if you can.
Yep.
But this is all very fascinating.
Cool. DRI. So other project working on is a traditional DRI project with Denali, and again, it's based on proven technology. It's been around for a while. We've partnered up with a company in Thailand, Meranti Green Steel, for the offtake of DRI. They're establishing a green EAF up there, and we've chosen to locate in the Midwest, where there are good magnetite resources, but we don't have. But the good thing about the Midwest is it doesn't have the same sort of cyclonic and general cost challenges as the Pilbara. Weather's a bit friendlier in the Midwest, and yeah, aiming for this. This is probably much less mature. We're still in sort of a pre-feasibility stage with this project, and so there are a couple of ways at the moment to produce green steel. One is the traditional blast furnace route, which is where most of the steel in the world is made. But there is a route and it's been around since probably the late 60s to reduce iron using a DRI plant, and then you can then process that DRI either in a BOF or in an electric arc furnace. The problem or the disadvantage of this is that it does require quite specific grades of iron ore, so you can't do this with your run-of-the-mill ore. But again, so I guess there's a belief that there's very little of that ore in the context of Australia. Of Western Australia, but we're currently producing 40 to 50 million tons a year of this stuff across Australia. So, in a very big DRI plant, it's a 2.5 million ton a year plant. So there is still a decent opportunity there. And running on natural gas, the plants are actually competitive. They're economic, and they do work, and you do get a material reduction in emissions. So it can be anywhere from half to a 75% reduction running on natural gas, depending on how you configure the plant. So it's still a material reduction. They're economic on gas, and the neat thing about the Energiron DRI is that they're actually what they call hydrogen ready. So even when running on natural gas, they just reform the natural gas into carbon monoxide and hydrogen, which is then used to reduce the iron ore. So basically, the rough term was unrust. Iron ore is just rust. So they unrust the iron ore back into iron. And so you can actually just run two pipes into the plant, one for hydrogen, one for gas, and swap back and forth between it. The limitation there being not upsetting the process. But that aside, if as long as you take more than a couple of days to swap from gas to hydrogen, there is no problem at all. So we're taking the view that start one of these, do it on gas, and then bring in green hydrogen progressively as you go along. And they've been around since 1957 was the first one. So they've been around for a while. And Energiron are the second largest technology out there. Midrex by Kobe Steel, who are the competing technology, have more plants. But between them, they have a lot of running plants, and they're still running, most of them in the Middle East, where natural gas is extremely cheap. But there's no real reason why you couldn't get one of them up here, aside from, I guess, the effort of standing up a project. And so I think one of besides making a start on producing low emissions iron, we think that this is an opportunity to kickstart a green hydrogen industry as well, because one of the challenges with green hydrogen is export. In order to export green hydrogen, you need very large scale storage and very large and then export facilities and then export infrastructure and ships and all the rest. that is massively expensive. You're much better off using the hydrogen onshore right next door. And that alone will take billions out from the capital expenditure of a hydrogen facility. And just in terms of scale, a 2.5 million ton a year DRI plant would consume about 150 kilotons a year of hydrogen. I think that equates to roughly 3 and a bit gigawatts of generation, which is not far off from what the whole of Western Australia uses. Granted, we're not a big population state too. And so, yeah, so we partnered up with Meranti. The objective, and I guess what we're aiming for is to target the automotive industry. That seems to be the industry that's happiest to pay a premium for lower emission steel. And some of it's just simple math. I mean, steel makes up less than 0.25% of a car, probably even less when you consider an expensive car. And I'll bet you they'll charge you at least that and then some for the privilege of having a car that's made from green steel. But again, our concept's not new. Azlan are doing the same thing in Canada at Dofasco. China's done a few of these plants. So the gas-fired the natural gas DRI plants that are hydrogen ready are popping up all over the place. And they make sense. I mean, it's something we can do now. It does reduce emissions, and then it's sort of whether or not you go to green hydrogen is sort of doesn't affect the actual investment in the project. So cool. That was it.